okay, starting from chapter 2 onwards, will be towards the Z language or Z schema already. Means that whatever that you learn from this chapter, mostly you are going to use in your Z schema later. Okay? So, from this chapter, of course, same thing, introduction to Z language first. Okay, so but we are going to learn a little bit about Z. What are the symbols that mostly you are going to use for your Z schema? Also, how to declare variables. And then at the end of this chapter will be how to start writing your Z schema. So that is the objective of this chapter. Okay? So, I think all of you know I just call Z because this is the actually how you pronounce the language that you are going to use for this course. Okay, actually, we are going to use a lot of mathematical notation later, and also set theory and logic. Okay, so for this course, we are going to use a lot of this. And then why it comes into the word Z here, actually from this one, the name is Zamilo, and from that then they start with Z and so on. But this one, of course, we won't ask you in the exam, whatever, what is the name and so on. Just that introduction for this, how we name or how we pronounce the language is Z language. Okay, and actually it's an old language. Okay, formal method, old formal method language, because we have many. The most popular for teaching students and bachelor students will be either Z, BDM, okay. The one that, if let's say you further study to your master and so on, there are other formal languages that you are going to learn also. Okay, but the easiest, I think, in terms of easiest language to learn is either Z or BDM. So for our class, we are going to go for Z language in this case, okay. So, as usual, last week we have actually discussed about model-based or model-based notation. Okay, so Z is one of the model-based, because later when you start writing Z schema and so on, you will see that you are going to represent the information in Z using state. Okay, so similar like you have your module. That's why for your assignment, normally I will ask you to choose modules and so on. So your state will be the module. We are going to use module as your state schema. Okay, then after that, your operation. Okay, for your assignment, we will ask you to find 3 operations. Okay, these operations will be the operations that you are going to use to show the behavior inside your system. Okay, so this Z is actually model based. So representing to represent state and behavior of the system. So how are we going to represent later is if you refer to the assignment from last week and this week, normally we will ask you to do the find the title, okay, and then list the modules, and also after that list the operations or functions under those modules. Because from your module that you choose, this is going to be the state schema for you. Okay, and then after that, okay, the operations that you are going to choose from a list of operations that you have, okay, those are actually to represent the behavior or operations of your system. Okay, behavior means something change state, remain, and so on. So you are going to use that, okay, to represent inside your schema later. Okay, so when we talk about state, okay, you are going to look also a few states later where you are going to have what we call as initial states, okay. We call as state space schema. We have also operation states, okay. We have also query states, okay. And then later after that, you are going to have any error schema states. And the last one will be what we call as complete schema states. Okay? So all these is actually possible states that you are going to have in your Z schema. And then you are going to show this through your assignment later. Okay? So these are actually the things that you should know when you start doing your Z schema later. So in your Z schema later, we are going to represent graphical construction lah. We call as schema. Okay, the graphical construction is a symbol that actually last week I showed you, but here is actually we call that symbol as a schema symbol. Okay, so it's not like your use case diagram, whatever that you have bubble all those things. No, this one is more on the one shape. Okay, where you have the upper part and below part. Okay, similar like you draw class diagram, you have the name of the class, you have the what attributes and operations and so on. So same case here is similar like that, just that you have the name of the schema, you have the predicate part, and you have the declaration part also. So all this is actually what you are going to know what to put inside each of these part. Okay, to show whether it is going to be your state space schema, or whether it is initial state, or whether it is going to be the any query state, operation states, and so on. Okay, so we call this graphical notation, we call as schema. Okay, so as I told you just now, okay, a lot of Z later you are going to use set theory. Okay, you are going to use set theory. So before we proceed with Z schema and so on, let's recap of what you have learned about set before. Okay, so because these symbols that you are going to use later will be mostly used inside your schema. Okay, so let's recap. So just to let you know, whatever that you do in your Z later is actually in set. Okay, but at the end of chapter, we are going to have a little bit different, where you can represent like something like data structure. So we call that as multi-set and so on. So that one is at the end of the semester. Okay, but when you start with your Z schema later, everything that you define, everything that you do is actually related to set. So when we say set, you have to remember, set data, okay, all your data is represented as set. So when we talk about set, the data cannot be duplicated. Means, let's say in the class here, I may have 2 Ellen, for example. Okay, let's say I have 2 Ellen, but in my set, I can represent only with 1 Ellen only, even though I have 2 people called Ellen. Understand? So means that when we talk about set, the data cannot be duplicated. Okay, but the arrangement of data is not important. Means that, let's say you have Ellen, you have Siti, you have Lin, whatever, the arrangement is not important. You can put Siti first, you can put Ellen the last one, doesn't matter how you want to rearrange the data. Okay, the order is not important when we talk about set. Okay, so this is recap that you have to actually remember about set, because when we discuss later, when you want to do relationship and so on, you have to know that the data inside set, it will not be duplicated, so it will point to the same data. Let's say I want to have student ID, then I have 2 Ellen, okay, so you are going to point to 1 Ellen, but here 2 student ID, because meaning that there are 2 students with the same name Ellen. You understand or not? Okay, so means that you have to remember, you cannot have student ID 1 Ellen, another student ID, another Ellen inside the same set, because only 1 Ellen data inside the same set. Okay, so when you have to make sure that, okay, when you do all this mapping, you have to remember the data inside the set cannot be duplicated. The way that you show the data, okay, the way that you show the data cannot be duplicated. You cannot have inside your set that Ellen, Siti, cannot. You have Ellen, Siti, Lim, for example. Understand? So you cannot have Ellen twice inside the data set. Okay? So that is actually what you have to remember, the first thing about set. Okay? Okay, so why we have this? This is actually why we have that. So we are trying to have no ambiguity of data, okay, and then make sure that it is different from each other. That's why we don't have duplicate data in set. And then each elements in the set, we are going to call elements or member. Each data inside the set, we are going to call elements or member. Okay, so I think all of you learned about this before. So it's just a recap for you to remember what you have learned before. Okay, so last week, okay, you have done a little bit about set last week, okay, in your tutorial 1. So actually, I cannot remember what is it called, like binary number, rainbow, whatever, all those things. If you remember the tutorial questions from last week, you have done a little bit of that about set last week in your tutorial. So normally, when you represent the data, you use set, curly braces is needed. Remember that. When you want to represent the data in your set, you have to use curly braces. Okay. So when you use curly braces, all the data inside the curly braces, this is the one that you cannot duplicate. Okay, so that one, I think you have actually done something a little bit of set last week already. So this is another example that you can actually represent set, where of course you use curly braces. Inside here are actually the data set. Okay, the data inside your set, where this data cannot be duplicated. Okay, here I put like this. What does equal means? Okay, I know that in your programming, equal mean compare. When you write programming, when you want to compare A, whether A is the same as B, comparing, you put double equal normally in your programming. But in Z, double equal does not mean compare. Double equals mean define as. Okay, define as. What does define as means? That you are telling people ocean here is actually consists of these 4 data. Okay, so that is what you mean by this statement. Equal in Z schema does not mean comparing. Okay, it means define as. So when you do like the algorithm, whatever, in your Z schema later, you want to do compare. Don't use double equal. Okay, don't use double equal. Use 1 equal only. Even though you are comparing right hand side with left hand side. Okay, you use 1 equal symbol only. Okay, double equal for Z will be meaning as define as. Okay, so the statement here means that ocean, the data of ocean is actually consists of these 4 data. Same thing for others. Example. Okay, so meaning that you have this data like this. So the meaning of double equal is actually define as. Okay, and then when you want to show set, remember curly braces is needed. Okay, curly braces is important to show the data in set. Okay, so the symbol. So from this slides onward, there will be some symbols that come into the slides where you have to remember all those symbols. Okay, remember all the symbols because in your test or in exam, the Z glossary shows all the symbols will not be given to you. So whatever that the symbols that you are learning from today's onwards, you have to keep in mind, you have to actually remember all those symbols, the meaning of all those symbols. Okay, first one, I think all of you have seen this symbol last week. Okay, in your tutorial. So this is member of. Okay, so this is member of. The /1 means not a member of. So normally this symbol, okay, we are going to use when we want to check the data whether exists or not in the database. For example, let's say customer, right? Normally customer, you want to add new customer or you want to add new staff, for example, doesn't matter lah, the staff, customer, whatever. Let's say you want to add new staff or new customer. Okay, so you have a list of customer in your database. Okay, you have maybe around 50 customers in your database. Okay, assuming that you have 50 customers in your database, then there is one name of customer in your system. Okay, so you want to add this customer your database. Okay, so first thing is, okay, when you want to add the customer into the database, you have to check, right, whether the customer name already exists or not in the database. Because remember, this is a set. If the customer that you want to add is Alan just now, in your database I have Alan already, then exists already, you cannot add. But if let's say you want to add Alan, but the Alan is not in your database yet, then you can add Alan into database. Because set, you cannot duplicate. You cannot duplicate data. So you have to make sure that the data does not exist. So how to show the data does not exist? We use not a member of. Okay, so how to read the statement? Actually, does Alan exist or not in the database? Okay, exist. So normally the symbol that we represent will be not a member of or a member of. But the way that we say the whole sentence is either exist or not exist. Do you understand? That's it. Let me show using Microsoft Word lah. Let me install first. Because every time in the lab, in the DK, we won't have this. For example, let's say I have customer, where the customer I have Alan, Kitty, Lynn, anybody lah, put lah, Sandy, okay, Andy, whatever lah, okay. So let's say these are my list inside my set lah. So now the new customer equals to let's say Alan. The name of the new customer is Alan. So when you want to write the statement, okay, in your Z schema, okay, I'm not using any variable yet. So the way that you write, you are going to write Alan. Okay, to check, you use member of this one or not lah. For now, okay. So either this or this one. For checking, let's say you want to check something, it's either this or this. Okay, So what it means here, actually, if let's say, okay, if let's say you want to add customer, remember, set cannot duplicate. So meaning that I want to add Alan into database. Okay, Alan into database. So Alan, I have to check whether Alan already exists or not. Okay, so if I want to add Alan into database, my system has to make sure that in my database, Alan does not exist yet. Right, because set cannot duplicate. Set cannot duplicate. So meaning that if you want to use that, you use this statement. Okay, so meaning that I am checking to make sure that Alan does not exist yet in my database. So the way to do it is you have to use not a member of symbol. Okay, not a member. Meaning that this statement saying that Alan is not a member of whatever data that I have in my set. So, wait lah. Alan does not exist. Sorry, must make sure that no Alan lah. Okay, so if you want to make it correct or not lah. Okay, so if you want to proceed, Alan does not exist, then this is true. But if let's say Alan already exists, okay, Alan already exists, then this is going to be false. So when you do something like a checking, you have to know whether in your database will provide you true or false answer. Okay, so if you want to add, normally you do this lah. Okay, so your data, if you want to proceed to make sure that your adding is successful, means that your data will not have this one yet. Okay, will not have this one yet. Then it is true. But if your data have this one, the answer is false. Means you cannot add Alan again. Okay, you cannot add Alan again because already exists. We cannot have duplicate data for Alan in our set. Remember that. That's why duplication is important not to have in our set. Okay, so means that when you do set, you have to remember cannot duplicate data, cannot duplicate data. Okay, so that is if let's say you want to check for adding customer into database. But if let's say your operation, one of the operation you want to do, update information, right? Update information of the customer. Then if you want to update information, update the customer info, for example, then your statement is to make sure when you want to update the information of one of your customer, maybe the handphone of the customer change. Okay, so you want to update the information of the customer. So if you want to update the information of the customer, first of all, that you have to check that your customer must exist in your system first. Okay, if your customer does not exist, how to update their information? Okay, so your customer must exist in the system. So in order for you to show exist, normally you do member of symbol. Okay, so the symbol member of, not a member of, is to show either the customer or whatever exists or not exists in your system. So normally when during tutorial whatever, sometimes I will just say, does the customer exist in the database or not? So when we say customer exists or not exists, you have to know the symbol is either this member of or not a member of. Okay, so remember that this one is to show. Normally this statement is to be used during operation schema later to check on your database. Okay, to check on your database. So you are going to use this a lot, this symbol a lot. So you have to know. Okay, another thing maybe some of you, I'm not so sure whether Miss Manlinda have informed you. Okay, so when you have this, this symbol, okay, so this is a symbol, right? Member of, So you will see that on the left side I put curly braces. On the right side I didn't put curly braces. Okay, so just to maybe under me I have explained during your tutorial. Okay, but just to remind you again that if let's say you have like this, on the left side of your symbol, left side, this one, right? Left side symbol, it's okay not to have curly braces. Okay, you put curly braces or without curly braces, no problem, no error. Okay, but on the right side, if let's say you have a set of data like this, means the whole data, you have to use curly braces. Unless later you use variable. Okay, for now we are not using variable yet. We are just using curly braces. So if you want to show the whole data in your set, you must use curly braces. Okay, but for the left side of the symbol, left side of the symbol is okay not to put curly braces. But if you want to put curly braces, there is no error there. If you feel confused, why no curly braces? Why this one got curly braces? Then put curly braces, no problem. Okay, so here I want to show that it is okay not to have curly braces on the left side of the symbol. Okay, so just remember that. But on the right side, okay, if you use variable, it's okay. Here no variable yet. I didn't teach you variable yet. If variable is okay not to have curly braces. But when you deal with data, means something that related to data, you must put curly braces. Okay? Variable is actually a variable to represent data. So when we talk about variable, this is not totally 100% data yet, because you are referring to data later. But let's say this is data. When data, you must put curly braces. Remember that. Okay, so that is for member of. Okay, so member of, not a member of. And of course, last week also, you see about empty set. So the symbol that we are going to use for empty set is this symbol. All of you have seen this symbol before. We are not going to use opening curly braces. For our Z schema, we are going to use only this symbol for empty set. Okay, just use this one for empty set. Okay, there are cases where you are going to have singleton set. Singleton sets means you have one data only inside your set, one data only. So that is what we call as singleton set. Okay, singleton set is not empty set. Empty set, empty set. Singleton means you have one data only inside your set. So it's actually inside the curly braces. Okay, so there are cases that, okay, to represent a single data. Okay, so we can do declaration later to represent a single data. Okay, so normally when we declare singleton, especially like something like you want to really have only one data where you do comparison with that. Okay, but if let's say you don't have singleton, it's seldom used lah. Okay, except you declare variable as single data. Okay, so that one is later lah. That one is later. But normally in a normal set, we seldom use single set data. Okay, so okay, subset. You have seen also subset before. Okay, subset is actually, I think you know lah what is subset lah. So subset is you have, let's say, two sets, set A and set B. So if set A symbol, let's say data is lesser than set B, we can say also set B subset. But if let's say set A is equal to set B, also subset. Okay, set A equal to set B, also subset. Set A less than set B, also you can use the symbol subset. Okay, so the symbol subset you have line here. So this is the symbol for subset. If let's say you want to use the symbol C without the line, we call this as proper subset. Different little bit. Proper subset cannot have set A equal to set B. Meaning that you can have set A less than set B, but you cannot have set A equals to set B. That is proper subset. Okay, so how do we want to differentiate these two? Normally, when you talk about data, okay, let's say whatever the whole data, you can have the same. There is one of the tutorial question that we will use proper subset also. So for example, from the tutorial, I just give you the scenario from the tutorial where in the hospital, you have a bed in the hospital where patients will occupy the bed if you are actually been admitted to the hospital. Let's say you have 100 beds in the hospital. So the patient that are going to occupy the bed can be a subset lah. Means that can be the same as total of the bed there. Means that you can have 100 patient equals to 100 bed. So, or you can have lesser patient than bed. Means that maybe you have 90 patients, bed is total 100. You can still use subset of. Okay, but if let's say you want to show something that link to the those, let's say, because when you have 100 patients occupy 100 bed means full already. So if let's say you have other patients come in that need to be admitted, so normally maybe you can put them on the waiting list. Okay, waiting list where to be admitted into the hospital. So one patient discharged, then you can take from the waiting list, then assign to the bed, right? Okay, so now you can make something of your scenario where if the bed or the patient, okay, is a proper subset of bed, means that proper, meaning that there are at least one free bed, meaning that implies that the waiting list is empty. You understand or not? Okay, let's say I have 100 bed, patient 98, Okay, so you can say that patient proper subset, proper subset, no equal, then bed. So means that we cannot have equal to 100, understand? Meaning that because I have three things, patient, bed, and waiting list. So I can say that if I have at least one free bed, I will say that nobody on the waiting list. Is it true or not? If I have, in my system, if I have one empty bed, at least one empty bed, I can say that nobody on the waiting list. Is it true or not? Yes, right. Faham tak? Okay, now we have to consider, because this is a scenario that you have to think of your system assignment later. Okay, so now I have in my system, I'm going to have three table, we call table in our database table, we call it table, right? I have table patient, I have table bed, I have table waiting list. Okay, so now I have 100 bed. Bed 1, bed 2, bed 3 until bed 100. Okay? Okay. Then I have patient. Patient 1, patient 2, patient 3, patient 4. So my original system, 100 patient can occupy 100 bed. Okay? 100 patient can occupy 100 bed. So means that I can put something like this in my system. Let's see, I show you that. Now you start confusing already. I don't confuse. Starting only. So let's say I have P for patient. I have 100 patient. Bed, I have 100 also. Now W is for waiting list. This one is up to us. How many? Yeah, I have this. Yeah. So now I have this. So I want to show that in my system, when I design my system, because I have 100 bed, then I can have as maximum as 100 patient to occupy the bed, right? Right. Maximum 100 can occupy the bed, right? Is it true or not? At one time, I can have maximum 100 patient occupy 100 bed, right? I cannot have 101 to occupy 100 bed, cannot. So means that I can show something like this. P can be a subset of B. Is it true or not? I can put like that. Yeah? So now this is just to say patient and bed. So now I want to link this with the waiting list. If let's say this one occupy, then we may have nobody on the waiting list, or we may have at least one inside the waiting list because already full. So there may or may not be patients on the waiting list. Okay, so we can have like that. But if let's say I want to show that if I put P, proper subset of P. Okay, so now means that my data P cannot be equal to 100. Because proper subset. Proper subsets means cannot be equal to 100 at all. So maximum of P here will be 99 only. Okay? So, if I have this scenario, do you think there is a P of people or not inside the waiting list? If let's say there is one empty bed here, do you think got person on the waiting list or not? What do you think? Nobody. Because waiting list will be there if you have bed full, right? So if you have this means, this statement means bed is full. Right. Bed is full means occupied by the patient. Occupied by patients. Okay, occupied by patients. Okay, and we may have somebody may have patients on the waiting list. Yeah, may have patients on the waiting list. Yeah, so if you have this, yeah, you have this. when you do this statement. But if you do this statement means that bag is not full. Okay, bag is not full. Because you cannot have, you have 99 patients, maximum 99 patients only. So there is at least one empty bag. So when there is one empty bag, what do you think about the waiting list? Do you think have one patient or two patients or not on the waiting list or not? Normally no, because now your bed is empty. So you have already put all the waiting list on, like occupy the bed. So nobody on the waiting list. So this one means that, the meaning should be nobody on the waiting list. Okay, nobody on the waiting list. So later, when you write in your Z statement, you can use this. Then you can use implies. You learn of implies, W equals to M. You can write like this, something like that lah. But of course, this one like not really straightforward lah. You are going to use variable and so on. This one is just to say what you are going to use later. Okay? So when you say that P patient does not occupy all the bed available, okay, means that there is still an empty bed in the system. Implies that, you know implies, right? You know implies, right? The word forgot about this script. Implies means that nobody inside the waiting list. So how to show nobody on the waiting list? You put W equals to M. Can understand or not this statement? Can understand or not? For now, you think can accept or not this statement? Something like that. Anybody who still don't understand? Can? Okay? So this statement is something that you may write later in your assignment. Okay? So you have to think like you are designing your system, but now you have to translate the meaning in mathematical notation. Okay? So of course this one I didn't use the correct variable yet. I just want to show scenario only. The variable, if you look at the variable, might not be the same. So you may have something that you are going to use later, something that different in the bit. But just to say that here, okay, when you do subset and proper subset, there are two meaning here. Okay, you can use it at different scenario. Okay, you can use at different scenario. Yeah. So this statement may or may not be used by you lah. Okay, but some of you may want to represent something in your state in your Z schema later. So you may need to show using statements. Okay, but of course this is not 100% correct yet because we are not using the variable and so on. I never teach you that yet. But just to understand the concept of subset and proper subset. Okay, subset and proper subset. Okay, understand this one Okay Can Okay, so this is the proper subset. So the symbol is like C only. Okay, no underline below. Underline means subset. When you want to use proper subset, no underline below. Okay, so A cannot be equals to B. Means that the data of A must be lesser only from B. Cannot be equal at all. Okay, so that is proper subset. Okay, power set. Have you seen this symbol before? Proper subset. Proper subset. Proper set. Proper kat dah. Power set. Now I also confused already. Power set. Have you seen this one before in your study last time? Yes. What does it mean? power set. Okay, so all combination. So, but of course, this statement is all combination in terms of mathematical notation. But later, okay, what we are going to do in our schema, if let's say you have database customer just now, right? But you don't know how many customers that you have inside your database, total records that you have. You don't know. You just know that you have customer in your database. So you want to show that your database can consist more than one records. Okay, you want to show in your system, your customer data in the database will have more than one records. Okay, will have more than one record. Can be empty or more than one records. One or more than one records. Okay, so you want to show that. But you don't specify how many. You don't specify only 200, only 1,000, only 10,000. You don't specify the maximum number. Okay, so if you don't want to specify the number, the most popular symbol that you need to use in your Z schema later is by using power set. So power set is actually used to represent, for example, set of data inside your database. Okay, if whether can be empty set, can be one data only, or can be more than that. But you don't need to tell or specify how many you want to have inside that. Okay, for example, when the customer, you want to register new customer, you don't need to check with the set maximum records that you have. If let's say you say 1,000 only, if exceed 1,000, then you cannot have anymore. So normally, the most popular symbol we are going to use later will be power set to represent our data. Okay, if you want to have, like just now I show you Allen City, there is more than one record already, more one data already. So to represent the data, okay, let's say I go to this one. Let's say this one, more than one data. So rather than I use this whole thing, I can show this as let's say more than one data. So how to show that? Actually, I can have name, my variable. I can put colon. Name variable normally is small letter. I can use power set of something here. Let's say name. Name I haven't done yet. What is name here? Means that, okay, power set here is to show that many records. Okay, many records. Rather than I use this, okay, then I can have something like this. Let's say I have name here. Is defined as this. Let's say I have this. Okay, then rather than I have this statement, then I can have, okay, so this is using variable now, a little bit of variable already, but don't worry how I declare later, we will see. But rather than you have a list of records listing for you inside curly braces, now later when you learn about variable declarations and so on, you just use the variable. Okay, but power set, I just want to explain about power set, is to represent empty set, one record or many records. Okay, so now I have many records here. So it's actually, you need to show by power set. Okay, by power set. Okay, so that is actually, later you will use something like this. You are not going to use like this, mostly. Because in your database, you may have many records. So you are not going to list one by one. Let's say you have 200, how are you going to list 200 here? So normally we are not going to use that. We are going to use variable to represent that. Okay? Yeah? So, power set. Another one, other than power set, is finite set. It's same as power set, same. The finite set is the same as power set. just that finite set, normally some people want to use, let's say, seat inside the bus, for example. You have 40 seats. 40 seats. You know, every bus in your system can have 40 seats only, for example. Or classroom, for example, tutorial room. Each group maximum, your tutorial maximum 24. Maximum 24, each tutorial group. So, if every bachelor tutorial group cannot exceed 24, rather than we use power set, we can also use finite set. Okay, because you know the exact only. You know the size only. You are not going to exceed from that. So, you know the size, rather than you use power set, you can use finite set. But the concept is the same. Normally for me, I am lazy to think about that. Normally, I will just use power set. So general, because power set is general for all. Okay? So, if you feel that you don't like to use finite set, straight away you just use power set. Okay? So, no need for you to worry about the size and so on. Because when you do system, okay, you want to have maximum, then you can do something else from that. Rather than use finite set, you can set a value, a maximum value. Okay, then you use that to do that. So you can use your variable power set. No need to use finite set. Okay, but the same thing happen. For finite set and power set, you don't have to worry whether you use finite set or power set. You can, whatever that you do will be the same. Just the symbol P and F only. P normally used for general. F is specific little bit. That's all. Okay. So for both finite set and power set, if you want to check, people will ask you, how many customers you have in your database? Something like that. So people will ask you how many customers that you have in your database. Because when you use power set, you don't know the number. When you use finite set, you may say 24, but that's not mean that 24 in the database. You may have 22, for example. So you want to know the exact number of your records that you have in your database. So you can use what we call as cardinality. Okay, in your maths, I think you have bar and then number bar. I think that is the symbol that you used before. But in our Z schema, in order to show the size or the total records that you are going to have in your database, we call this as cardinality. The symbol will be hashtag symbol. Okay, so let's say I have set S just now. Let's say just now name, right? Ellen, all those things. So if you go to that, I will have, let's say, Ellen, how many? 4 or 5 records. So the answer will be 4 or 5 according to how many set that you have inside that. Okay, so let's say I have 1 to 4 here. The total will be 3. Okay, it's actually how many records that you have inside the set there. How many data that you have inside that. Okay, so if you go to the, just now, this one, let's say I use hashtag name. Okay, my answer will be 1, 2, 3, 4, 5, 6. So my answer will be 6. So that is cardinality. Okay, that is cardinality. To show you how many records that you are going to have. Okay, so that is cardinality. Okay, the next one, the next symbol, infinite set. Okay, this is the one that you have to remember, okay, to use with your number. Okay, so in Z schema, we are following the original SPI-VZ, okay. We need to use only 2 infinite set only. The rest we cannot use. The rest we cannot use. So we can only use either N or Z. Okay, N is actually 0 onwards, whereas Z can be positive or negative integer. Okay, other than that, let's say you have price 19 ringgit 50 cent. Cannot show as decimal. Okay, you must show either N or Z only. You cannot use Q, you cannot use R or A and so on. Cannot. So remember, even though in our Microsoft Word there is Q, there is R and so on, the only 2 type or set that you can use to represent number will be N or Z only. So I will not see Q or R inside your schema later. Cannot see. So the only data, even though you have, let's say weight or price, whatever, is all totally like decimal points. You cannot represent that. You have to think like integer only. Okay, so either N or Z only can be used. So this is infinite because like programming, you have the size, right? Decimal or whatever, you have to have long or whatever. So you need to declare that. But here, we don't care about the size. 1 million, 2 million, we don't care about that. We just say that it's infinite set, you can represent any numbers. Okay, so we don't care the maximum value, we don't care about the minimum value and so on. No. Okay, so we just say infinite set. So we don't care about the size because this is not the programming yet. This is not programming. So we will assume any numbers, integer number can be accepted in our system. Okay, decimal we cannot represent. Remember, only N or Z can be used in our schema. Okay, equality. Okay, this is the one that you want to compare, you want to assign, whatever. You use equal symbol only. Okay, no need to use double for comparing and so on. No need, just use equal. Not equal, you have to use, not equal means this one, this symbol, not equal. Okay, so you have to use this symbol to represent your statement inside your Z later. Okay, that is equal. Arithmetic operations, normally no problem. Plus, minus, times, no problem. But because we are using N and Z only, for divide, you have to use the keyword diff. Okay, for modulus, to get the remainder, you use MOD. Same as your tutorial 1 last week. Okay? Okay, so you have to make sure that you use these two. Plus, minus, no problem. Times, no problem. Okay, just that this one. Okay, this divide and modulus, because this is only for integer. These two are only for integer. For real, actually R, if let's say you go for other how to say, system, we can use the equal symbol, that one. But for us, because we are following SPI VZ, we are not we cannot use R. We cannot use R. Okay? So union, intersection, all these things. I think all of you know what is union. Okay, union is combination of both. So normally, when are you going to use union? When you want to add customer just now. Okay, you have 50 customer. Okay, so now you want to add another customer. The customer does not exist yet in your system. So you want to add the customer to become 51. So when you add the customer, you use union symbol. Okay, you want to add the customer, you are going to use union symbol. Okay, for the intersection, normally you want to show something that in your condition and so on. Let's say those who occupy the bed cannot be on the waiting list, right? Those who occupy the bed cannot be on the waiting list. So means that bed intersect with waiting list must be equals to empty set. You understand that? For example, intersection, bed, so you can say also those who occupy the bed and intersection, where is it? This one. And wait, okay, those who occupy the bed cannot be on the waiting list. So you can put equals to empty set. Okay, understand that? Those who occupy the bed and those who are on waiting list cannot intersect each other. So means that intersect each other equals to empty set. Okay, so this is another term lah. This is, you can use intersection here. Okay, you can use intersection here. Okay, so the next one is disjoint. This is the one on disjoint just now. Okay, where you have empty set. So we call this as disjoint set. Intersection also. So this is the one that I showed you just now, where those who are on the using or actually patient in the hospital, okay, who occupy the bed cannot be on the waiting list. So these two intersect must be empty set. We call this as disjoint set. Okay, so use intersection. normally if you want to remove the data, let's say the customer is actually you want to remove the customer from your database. So you have to use backslash. Of course, now the system, you are not removing, you are just transferring the customer to another block or whatever. But for our, because we are analyzing the system, we are actually specify the requirements and so on, we have to show that this data will be removed from this database. Even though you transfer, then you add into another database, that one you add. But you have to show that from here, you remove the data. So, how to remove? You use backslash symbol. Okay? Backslash symbol, set difference to remove the data. Okay, so this one, just remember the symbol first. Okay, because this one, when you go for set schema, all these symbol will come. All this symbol will come into. Complement, okay, is actually other than that, okay, like similar like not and so on. So I seldom we use, but it's up to your system lah. But you can have complement other than that. It's like if here and not here, something like that, not lah. Other than that lah. Okay, so that is complement. So you can use, but this one I think seldom student will use this, but you can use this in your Z schema. Okay, set comprehension. You have seen some a little bit in your tutorial last week, or you want to take a few minutes break? Can continue, or you want to take a few minutes break? Okay, I'll give you a few minutes break. Then after that, I'll continue with set comprehension.